If your self-briefing for the ILS approach at Ellis Airport in Jacksonville, North Carolina was your dress rehearsal, then think of setting up for the approach as preparing the stage for your grand performance. When you set up for an approach, you not only want to tune in and set up every radio you'll need in the approach, but you also want to set in backups where possible and make sure every radio is doing something, that nothing in your avionics arsenal gets a free ride. Having all your radios set up early means you'll have fewer tasks and distractions during the approach itself. And that means you'll have time to focus on tracking the localizer and glide slope with more precision to end up in the best possible position for a smooth, safe transition to the landing. When you set up your avionics, you'll want to start with your nav radios. If you're still navigating on the airway, set the airway up on your nav2 radio so you can go ahead and set your nav1 radio up for the ILS. Then make sure that the nav GPS switch is set to the nav position, so it's using the nav1 radio for its information and not the GPS. Trying to navigate from the wrong system is guaranteed to give you very confusing information, and it can be quite dangerous. Next, go to the nav1 radio and dial in the localizer frequency of 108.7. As you know, tuning the localizer frequency also automatically tunes the glide slope receiver. Then check your localizer identifier. If you are still quite a distance from the airport, you might not be able to receive the identifier yet. Then set the final approach course 052 in the number 1 OBS. Why? Well, even though the OBS setting has absolutely no effect on the needle indication, it's a great reminder of your final approach course. Now, what frequency do you put into the nav1 standby position over here? Well, if the missed approach nav aid were a VOR, that VOR frequency is what you'd want to put right there in the standby position. But as you know, on this approach, the missed approach nav aid is an NDB. However, if you miss the approach here at Ellis Airport, Wilmington International Airport would probably be your alternate, so you would use the Wilmington VORTAC frequency of 117.0, and that would be a great choice in nav1 standby position. Now, move down to nav2. During the approach, nav2 should be set on whatever will best help your position awareness. If you had VOR cross radials that identified fixes on the approach, you would set nav2 to that VOR's frequency. And entering the Jacksonville localizer frequency in the standby position sets you up to complete a localizer-only approach if your nav1 radio should die for some reason. You would only have to push the flip-flop button and bingo, you would shift your scan to the nav2 indicator. Now, tune the ADF receiver to Ellis locator outer marker, frequency 261, and listen for the identifier OA. Next, set your timer up so you can start the time as you cross Ellis. That way, if you end up flying the approach in a localizer-only mode, you'll be all set for determining the missed approach point using time. Now move up to the audio panel. Select the marker beacon audio and test the lights. Then set the sensitivity to low for the approach. By setting the sensitivity to low, you reduce the area where you can pick up the marker beacon signal, and that gives you a more accurate position fix on the localizer. Now, nothing in this approach says GPS, but as you already know, this ILS has DME information available. And you also know that GPS can often substitute for DME. So why not use the GPS to get DME information here? Well, the simple answer, You're not allowed to when the DME information comes on the localizer frequency. You see, the transmitter for the DME installation is somewhere near the localizer antenna off the far end of the runway. And that's not the same place as the airport reference point that the GPS database uses for the airport location. In fact, at a big airport, the difference between them could be a mile or more. But don't ignore the GPS, because you can't find a better tool for position awareness. So what can you do with the GPS? Well, set it on LS-NDB. The NDB is required to shoot the approach, and it is in the database. Not only will you get accurate guidance for transitions and the missed approach, but you'll get distance information too. The distance from Ellis, right over here, to the runway threshold is 6 nautical miles. 5.6 plus 0.4, that equals 6 nautical miles. So your GPS distance readout from Ellis will let you know continuously where you are during the approach. Now, how about your communications radios? If you're already talking to approach control on COM 1, go ahead and enter the Jacksonville Unicom and CTAF 123.0 in the standby. If the airport had a control tower, you'd enter the tower frequency in the standby instead. This way, you'll be ready to swap frequencies with the press of a button when ATC tells you to. In COM 2, you might enter Jacksonville's AWOS frequency 124.475. At a towered airport, you might even enter the ATIS frequency instead of the AWOS. For the standby, if it's a towered airport, you might put ground control in. Now in this case, you might put Wilmington Approach in here as a backup to COM 1. Finally, use your audio panel as a checklist to make sure you've thought of everything. Start from the left to the right, and here you have COM 1 and COM 2 set, NAV 1 and NAV 2, the marker beacons and DME. Well, GPS is set in place of DME in this case, and last comes the ADF, and that's set up. So it looks like you haven't missed a thing. The final part of your setup is to complete your before landing checklist. That way you'll have nothing left to do except fly the airplane. Well, as you can see, by setting up the approach and possible backups when you have plenty of time to concentrate on doing it correctly, you set the stage for a great performance. You'll have less work to do during the approach itself and be able to fly a better, smoother, and safer approach.